Today we're going to be testing the NCP1631PFCGEVB Interleaved Power Factor Correction Evaluation Board by ON Semiconductor. The equipment we'll be using today will be our Chroma AC power source, and we will also be using an AC power meter. And our AC source will be hooked to our input connector on our board. Our output connector for our 400 volt PFC stage will be our red positive, black negative. We will have a voltmeter on the output of the 400 volt output. We will also have a high voltage differential probe hooked up to the 400 volt output. And we will also have a DC input of 15 volts applied to our VCC bias input. And then over here we will also have a current probe which will be hooked up to measure our current on our input. And as stated earlier, we have our DC supply, which is going to be our 15 volt input voltage. We also have a Chroma DC electronic load. And up here we have our oscilloscope. And we have our differential probe as channel 1 and our current probe as channel 2. To begin test 1, first we're going to make sure that we have our AC source set to 115 volts AC, 60 Hertz. Next we're going to make sure that our DC electronic load is set to 0.8 amps or 800 milliamps, and we're going to turn that load on. And once our load is applied, we're going to power up our board by first turning on our AC source, and then we're going to once again make sure our VCC bias voltage is 15 volts and turn it on. And here we can see that we have our PFC output of between 370 and 409 volts DC. And next we're going to make sure that our power factor is over 0.98, which it is. And then next we're going to make sure that our THD is below 13%, which it also is. And lastly, we'll calculate our efficiency, which in this case turns out to be approximately 96%, which is acceptable. And this concludes test 1. To begin test 2, first we're going to make sure that our input current is sinusoidal. This is our blue wave on the oscilloscope, and it is sinusoidal. And next we're going to increase our input voltage to 230 volts AC and switch our frequency to 50 Hertz. And once again we're going to check our power factor. In this case we're going to make sure it's above 0.97, which it is. And then we're going to also check once again that our THD is below 13%. And once again we're going to measure our efficiency. And in this case it turns out to be approximately 97.5%, which is acceptable. And we also verify once again that our PFC output voltage is between 370 and 409 volts DC. And this concludes test 2. And to begin test 3, first we're going to turn our AC source voltage down to 90 volts AC and 60 Hertz frequency. And next we're going to slowly ramp down the input voltage. And as we do this, you can see that our OCP, or overcurrent protection, will start to kick in. And here we can see that our overcurrent protection is kicking in because our input sine wave is starting to flatten out or clip. And of course, the more we turn it down, the more we'll see this clipping. And this concludes test 3. And for test 4, first we're going to set our AC source back to 115 volts AC. And next we're going to go ahead and turn off our VCC bias voltage. Now we're going to set the trigger on our oscilloscope to window mode, and the trigger will occur outside the limits of 200 volts. And we're also going to make sure to compress the scale so that we can see quite a bit of our waveform on our oscilloscope. And now we're going to place it into single acquisition mode. And now we'll turn our VCC bias voltage back on. And here we can see our output voltage maxes out at approximately 271 volts, which is well within our specification of being below 424 volts. And this concludes test 4. And for our last test, test 5, first we're going to power down our VCC bias voltage. Next we're going to power down our board. Next, we're going to make sure that our DC electronic load is now set for 0.07 amps or 70 milliamps. We're going to make sure that it is still turned on, and we're going to make sure that we have almost zero voltage here on our output, as we are about to be manipulating the board itself. Next, on the board itself, we're going to take our positive clip from our differential probe, and we're going to place it right here on this pin, which is DRV1. And after we safely have that clip connected to DRV1, we're going to turn back on our AC source, and then we're going to turn back on our VCC bias voltage. And here, once again, we can see we have our PFC voltage on our output. And finally, on our oscilloscope, using our scale, we can zoom into our current waveform and see our switching frequency, which in this case will be about 50 kilohertz. This concludes the test of the NCP1631PFCGEVB Interleaved Power Factor Correction Evaluation Board. For more information, please visit www.onsemi.com or contact an authorized distributor.